Now, they said that these differences are first differences in shape, because things are angular, circular, and square. Second, differences in arrangement, that is, insofar as the indivisible bodies are prior or subsequent. Third, because differences in position insofar as these bodies are in front or behind, right or left, or above and below. Hence they said that one being differs from another either by rhythm, which is shape, or by intercontact, which is arrangement, or by turning, which is position. He illustrates this by using the letters of the Greek alphabet, which differ from each other in shape, just as in our alphabet one letter also differs from another, for A differs from N in shape. Again, AN differs from NA in arrangement, because one letter is placed before the other. And one letter also differs from another in position, as Z from N. Just as in our language we also see that semivowels cannot stand after liquids preceded by mutes in the same syllable. Therefore, just as license and silence come from the same letters as a result of the letters being disposed in different ways because of this threefold difference, in a similar fashion, different species of things are produced from the same indivisible bodies as a result of the latter being disposed in different ways. The second respect in which these philosophers agreed with the ancients is this: just as the ancient philosophers neglected to posit a cause which accounts for motion in things, so also did these men. Although they would say that these indivisible bodies are capable of self-motion, thus it is evident that these philosophers mentioned only two of the causes. All of them spoke of the material cause, and some of the efficient cause. But during the time of these, here he gives the opinion of the Pythagoreans, who held that numbers are the substances of things. In regard to this, he does two things. First, he gives their opinions about the substance of things, and second, their opinions about the principles of things at but the reason. In regard to the first, he gives two reasons by which they were led to assert that numbers are the substances of things. He gives the second reason, where he says, moreover, since they considered. He says that the Pythagoreans were philosophers who lived during the time of these, that is, they were contemporaries of some of the foregoing philosophers, and prior to them because they preceded some of them. Now it must be understood that there were two groups of philosophers. One group was called the Ionians, who inhabited the land which is now called Greece. This group originated with Thales, as was pointed out above. The other group of philosophers were the Italians, who lived in the part of Italy which was once called Greater Greece and is now called Apulia and Calabria. The leader of these philosophers was Pythagoras, a native of Samos, so called from a certain city of Calabria. These two groups of philosophers lived at the same time, and this is why he says that they lived during the time of these and prior to them. These Italian philosophers, also called Pythagoreans, were the first to develop certain mathematical entities, so that they said that these are the substances and principles of sensible things. He says that they were the first because the Platonists were their successors. They were moved to bring in mathematics because they were brought up in the study of these sciences, and therefore they thought that the principles of mathematics are the principles of all existing things. For men are wont to judge about things in terms of what they already know, and since among mathematical entities numbers are first, these men therefore tried to see resemblances of natural things, both as regards their being and generation in numbers rather than in the sensible elements, earth, water, and the like. For just as the foregoing philosophers adapted the attributes of sensible things to those of natural things because of a certain resemblance which they bear to the properties of fire, water, and bodies of this kind, in a similar fashion these mathematicians adapted the properties of natural things to the attributes of numbers when they said that some one attribute of number is the cause of justice, another the cause of soul and intellect, and still another the cause of opportunity, and so on and for other things. And in this way, the attributes of numbers are understood to be the intelligible structures and principles of all things appearing in the sensible world, both in the realm of voluntary matters, signified by justice, and in that of the substantial forms of natural things, signified by soul and intellect, and in that of accidents, signified by opportunity. Strange and obscure views about the principles of things, hidden principles, numbers. Moreover, since they, here he gives the second reason which motivated them, for they thought of the attributes of harmonies, musical consonants, and their ratios or proportions in terms of the nature of numbers. Hence, since harmonious sounds are certain sensible things, they attempted by the same reasoning to liken all other sensible things, both in their intelligible structure and in their whole nature, to numbers, so that numbers are the first things in the whole of nature. For this reason, too, they thought that the principles of numbers are the principles of all existing things, and they said that the whole heaven is merely a kind of nature and harmony of numbers, a kind of numerical proportion similar to the proportion found in harmonies. Hence, whatever they had revealed or had shown which they could adapt to numbers and harmonies, they also adapted both to the changes undergone by the heavens, as its motion, eclipses, and the like, and to its parts, as the different orbs, and to the whole arrangement of the heavens, as the different stars and the different figures in the constellations. And if anything was lacking in the observable order of things that did not seem to be adapted to numbers, they called it in. That is, they invented something new in order that their whole undertaking, which was to adapt sensible things to numbers, might be made complete until they had adapted all sensible things to numbers, as is evident in one example. For the number 10 seems to be the perfect number because it constitutes the first limit and contains within itself the nature of all numbers, for all other numbers are merely a kind of repetition of the number 10. This is why Plato counted up to 10, as Aristotle says in Physics. Hence, Pythagoras also said that the spheres which move in the heavens are 10 in number. Although only 9 of these are observable, we observe 7 in the motions of the planets, an 8th in the motion of the fixed stars, and a 9th in the daily motion, which is the first motion. But Pythagoras adds a 10th sphere, which was that of the counter-earth, that is, which is moved in the opposite direction to the motion in the lower spheres, and therefore produces a contrary sound. For he said that a kind of harmony results from the motion of the celestial bodies, so that just as a harmony is produced from a proportion of contrary sounds of low and high notes, in a similar way he claimed that in the heavens there was a single motion in the opposite direction to that of the other motion in order that a harmony might result. According to this position, the daily motion belonged to the 10th sphere, which moves from east to west, the other spheres being revolved in the opposite direction from west to east. In fact, according to him, it could have been the 9th sphere, which first revolved all the lower spheres in the opposite direction to the first motion. The things that pertain to this opinion of Pythagoras are considered more extensively and more definitively in the last books of this science. Lecture 8, The Pythagoreans' Doctrine of Contraries. But the reason we have come to examine these philosophers is that we may also learn from them what they hold the principles of things to be, and how these principles fall under the causes already described. Now, these men also seem to think that number is the principle of existing things, both as their matter and as their attributes and states. According to them, the elements of number are the even and odd. Of these, the latter is limited and the former is unlimited. The unit is composed of both of these, since it is both even and odd, and number is derived from the unit. And number, as has been stated, constitutes the whole heaven. But other members of the same school say that the principles of things are 10 in number, which they give as co-elements. The limited and unlimited, even and odd, one and many, right and left, masculine and feminine, rest and motion, straight and curved, light and darkness, good and evil, the quadrangular and rectangular. Alcmaeon of Croton seems to have formed his opinion in the same way, and either he derived the theory from them or they from him. For Alcmaeon, who had reached maturity when Pythagoras was an old man, expressed views similar to those of the Pythagoreans. For he says that many things in human affairs are in twos, calling them contrarieties, not distinguishing as these men had distinguished them, but such as are taken at random. For example, white and black, sweet and bitter, good and evil, small and great. It is true that this philosopher threw out vague remarks about the other contrarieties, but the Pythagoreans have declared both what the contrarieties are and how many there are. From both of these, then, we can gather this much, that contraries are the principles of existing things. But how many they are and that they are, these we must gather from other thinkers. That way in which many principles can be brought together under the causes described is not clearly expressed by them, although they seem to allot their elements to the species of matter. For they say that substance is composed and molded out of these as something inherent. From these remarks, then, it is possible to get an adequate understanding of the ancient philosophers' meaning who said that the elements of things are many. Here he states what the Pythagoreans had to say about the principles of things. In regard to this, he does two things. First, he expounds their opinion about the principles of things. Second, he indicates to what genus of cause the principles laid down by them are reduced at from both of these. In regard to the first, he gives three opinions. The second begins at the words, but other members, and the third at Alcmaeon of Croton. He says first, then, that the reason he came to examine the opinions of the Pythagoreans is that he might show from their opinions what the principles of things are and how the principles laid down by them fall under the causes given above. For the Pythagoreans seem to hold that number is the principle of existing things as matter, and that the attributes of number are the attributes and states of existing things. By attributes we mean transient accidents, and by states permanent accidents. They also held that evenness of number is justice because of the equality of division. Such a number is evenly divided into two parts rightly down to the unit. For example, the number 8 is divided into two 4s, the number 4 is divided into two 2s, and the number 2 into two 1 units. And in a similar way, they likened the other accidents of things to the accidents of numbers. In fact, they said that the even and odd, which are the first differences of numbers, are the principles of numbers, and they said that even number is the principle of unlimitedness, and odd number the principle of limitation, as is shown in the physics. But in reality, the unlimited seems to result chiefly from the division of the continuous. An even number is capable of division, but an odd number includes within itself an even number plus a unit, and this makes it indivisible. He also proves this as follows. When odd numbers are added to each other successively, they always retain the figure of a square, whereas even numbers change their figure. For when the number 3 is added to the unit, which is the principle of numbers, the number 4 results, which is the first square, because 2 times 2 equals 4. Again, when the number 5, which is an odd number, is added to the number 4, the number 9 results, which is also a square number, and so on with the others. But if the number 2, which is the first even number, is added to the number 1, a triangular number results, the number 3. And if the number 4, which is the second even number, is added to the number 3, there results a septangular number, the number 7. And when even numbers are added to each other successively in this way, they do not retain the same figure. This is why they attributed the unlimited to the even and the limited to the odd, and since limitedness pertains to form, to which active power belongs, they therefore said that even numbers are feminine and odd numbers masculine. From this too, namely the even and odd, the limited and unlimited, they produce not only number, but also the unit itself, unity. For unity is virtually both even and odd, because all differences of number are virtually contained in the unit, all being reduced to the unit. Hence, in the list of odd numbers, the unit is found to be the first, and the same is true in the list of even numbers, square numbers, and perfect numbers. This is also the case with the other differences of number, because even though the unit is not actually a number, it is still virtually all numbers, and just as the unit is said to be composed of the even and odd, in a similar way number is composed of units. Indeed, the heavens and all sensible things are composed of numbers. This was the sequence of principles which they gave. But other members? Here he gives another opinion which the Pythagoreans held about the principles of things. He says that among these same Pythagoreans there were some who claimed that there is not just one contrariety in principles as the foregoing did, but 10 principles which they give as co-elements, that is, by taking each of these principles with its co-principle or contrary. The reason for this position was that they took not only the first principle, but also the proximate principles attributed to each genus of things. Hence they posited first the limited and the unlimited, as did those who have just been mentioned, and subsequently the even and the odd, to which the limited and unlimited are attributed. And because the even and odd are the first principles of things, and numbers are first produced from them, they posited third a difference of number, namely the one and the many, both of which are produced from the even and the odd, again because continuous quantities are composed of numbers, inasmuch as they understood numbers to have position, for according to them the point was merely the unit having position, and the line the number 2 having position. They therefore claimed next that the principles of positions are the right and left, for the right is found to be perfect and the left imperfect. Therefore the right is determined from the aspect of oddness, and the left from the aspect of evenness. But because natural bodies have both active and passive powers in addition to mathematical extensions, they therefore next maintained that masculine and feminine are principles. For masculine pertains to active power, and feminine to passive power. Of these, masculine pertains to odd number, and feminine to even number, as has been stated. Now it is from active and passive power that motion and rest originate in the world. Of these, motion is placed in the class of the unlimited and even, because it partakes of irregularity and otherness, and rest in the class of the unlimited and odd. Furthermore, the first differences of motions are the circular and straight, so that as a consequence of this, the straight pertains to even number. Hence they said that the straight line is the number 2, but that the curved or circular line, by reason of its uniformity, pertains to odd number, which retains its undividedness because of the form of unity. And they posited principles not only to account for the natural operations and motions of things, but also to account for the operations of living things. In fact, they held that light and darkness are principles of knowing, but that good and evil are principles of appetite. For light is a principle of knowing, whereas darkness is ascribed to ignorance. Good is that to which appetite tends, whereas evil is that from which it turns away. Again, they said that the difference of perfection and imperfection is found not only in natural things and in involuntary powers and motions, but also in continuous quantities and figures. These figures are understood to be something over and above the substance of continuous quantities, just as the powers responsible for motions and operations are something over and above the substances of natural bodies. Moreover, with reference to this, they held that what is quadrangular, that is, the square and the rectangular, is a principle. Now a square is said to be a figure of the 4 equal sides, whose 4 angles are right angles, and such a figure is produced by multiplying a line by itself. Therefore, since it is produced from the unit itself, it belongs to the odd numbers. But a rectangle is defined as a figure whose angles are all right angles, and whose opposite sides alone, not all sides, are equal to each other. Hence it is clear that just as a square is produced by multiplying one line by itself, in a similar way a rectangle is produced by multiplying one line by another. Hence it pertains to the even numbers, of which the first is the number 2, Alcmaeon of Croton. Here he gives the third opinion of the Pythagoreans, saying that Alcmaeon of Croton, who's so named from the city in which he was raised, seems to maintain somewhat the view as that expressed by these Pythagoreans, namely that many contraries are the principles of things. For either he derives the theory from the Pythagoreans, or they from him. That either of these might be true is clear from the fact that he was a contemporary of the Pythagoreans, granted that he began to philosophize when Pythagoras was an old man. But whichever happens to be true, he expressed views similar to those of the Pythagoreans, for he said that many of the things in the realm of human affairs, that is, many of the attributes of sensible things, are arranged in pairs, understanding by pairs opposites which are contrary. Yet in this manner he differs from the foregoing philosophers, because the Pythagoreans said that determinate contraries are the principles of things, but he throws them in, as it were, without any order, holding that any of the contraries which he happened to think of are the principles of things, such as white and black, sweet and bitter, and so on. From both of these, here he gathers together from the above remarks what the Pythagoreans thought about the principles of things, and how the principles which they posited are reduced to some genus of cause. He says then that from both of those mentioned above, namely Alcmaeon and the Pythagoreans, it is possible to draw one common opinion not expressed by earlier thinkers. The principles of existing things are contraries. This must be understood with reference to the material cause. For Empedocles posited contrariety in the case of the efficient cause, and the ancient philosophers of nature posited contrary principles such as rarity and density, although they attributed contrariety to form. But even though Empedocles held that the four elements are material principles, he still did not claim that they are the first material principles by reason of contrariety, but because of their natures and substance. These men, however, attributed contrariety to matter.